A flask contains m1 kg of air. When the temperature of the air changes from 0 degrees C to 100 degrees C, 1 gram of air leaves the flask. Find m1. This diagram shows the flask that contains the air. The white dots represents the molecules of the air. The question mentions that the temperature of the air changes from 0 degrees C to 100 degrees C. That means that the initial temperature of the air in the flask is 0 degrees C, and we denote it as a T1 equal to 0 degrees C. The final temperatures of the air in the flask is T2 equal to 100 degrees C. So when it reaches this temperature, 1 gram of air leaves the flask. So in these diagrams, we denote the M1 as the original original mass of the molecule for the air in the flask, and the M2 is the remaining mass of the air in the flask. But the question never mentions what is the exact value of the M1 and M2. What we know is only that the mass of the air that leaves the flask. So that means instead of knowing the value of M1 and M2, now we know that M1 minus M2 equal to 1 gram. To find the M1, we start from PV equal to nRT, equation of state or ideal gas law. So that means we assume the air in the flask is the ideal gas. And by substituting the N by this M over M, then we can introduce the mass of the air in these equations. And now we change this small m as a subject of the equation. We will get PVM over RT, where the capital M is the molar mass of the air in the system, or in this system, the air in the flask. Now we can, based on these equations, write down equation number 1 and equation number 2 for the two states mentioned in the equations, where when the temperature T1 equal to 0 degrees C, we have M1 equal to P1 V1 M over RT1. We name this as equation number 1, and for the state number 2, when the temperature is T2 equal to 100 degrees C, we have M2 equal to P2 V2 M over RT2. So this one we call is we name it as equations number 2. Now we take equation 1 divide by equations 2, we'll get M1 over M2 equal to T2 over T1. The molar mass M and M will be cancelled out in these two equations, and the gas constant also will be cancelled in these two equations. Now, since these volumes of V1 and V2, they are the same, so they also be cancelled. V1 and V2 are the volumes of the gas, which is the same as the volume of the flask, and then they should be the same, so we can cancel out. And for the pressure, P1 and P2, they are also the same. Please take notes that this P2, of course, it is referred to the pressure of the gas in the flask after some of the molecules of the air is being released. So when we heat this gas to 100 degrees C, of course the pressure in the flask would be increased. But since this flask is open, so some of the gas is allowed to leave, then the pressure in the flask will be adjusted back to the same pressure as the initial one, and the two pressure in the flask, they are the same, and also they are the same as the pressure in the surrounding. That's why P1 same as a P2. Now after we got these expressions, then we changed, that means we know what is the relationship between the M1 and M2, and we write this M2 equal to T1 or T2 times the M1. So this is a relationship between the initial mass of the molecule in the flask and the remaining mass of the air molecule in the flask. Bear in mind that just now we already mentioned that the M1, M2 itself, we do not know what is their value, but we do know that the M1 minus M2 is equal to 1 gram. So now we can write down M1 minus M2 equal to M1 minus this M2 is substituted by this expression. So it is T1 over T2 times the M1. Okay, now the right hand side, we factorize the M1. We'll get M1 times 1 minus T1 over T2. But our aims is to find what is the M1. So we change the M1. We change this M1 as the subject and bring the whole things in the bracket to the left. We'll get M1 minus M2 divided by 1 minus T1 or T2. We don't touch about this M1. We treat this M1 minus M2 as one single terms because later we can substitute this M1 and M2 as 1 gram to get to get the value of this M1. That's why we don't group this M1 and this M1 together. Okay, we treat this M1 and M2 as single terms, which is equal to 1 gram. The value equal to 1 gram. Now we can substitute value. M1 minus M2 equal to 1 gram in kg is 1 times 10 to the power of negative 3. And the temperature for T1 is 0 degrees C, T2 is 100 degrees C. So please remember to convert the temperature into Kelvin. So we have 273.15 divided by 373.15. Then we'll get 3.73 times 10 to the power of negative 3 kg, which is in gram is equal to 3.73 gram. So this is the original mass of the air in the flask when the temperature is 0 degree C. Now, of course, if we want, we can find what is M2, the remaining mass of the air in the flask, but we don't do that because the question is only want us to find what is M1, and the answer is 3.73 gram.